It's Mr. Bryce, and here's my information. We're with Common Core Algebra 2 non-regents. We're on Unit 6, pages 33 to 36. Hey, if you don't like what I'm saying, just go to the guy that made this all up, so grab your popcorn and hang on for the ride. It's going to be a nice show. We've already seen quadratic functions used to model a wide variety of real-world applications. So, right now in this lesson, we're going to focus on quadratic models to predict and optimize. Make it the best. Almost always, our solution will depend on either the intercepts, the x-intercepts, or the y-intercept, or the turning point of the quadratic model. That's where it changes direction, the vertex. An object is fired upwards with an initial velocity of 112 feet per second. Its height in feet above the ground as a function of time in seconds since it was fired, given by the equation. There we go. At what height was the object fired? Let me see. You fire it. What happens? We know that, gee whiz, time must have been 0. So all you have to do is plug 0 in for t. So what's h of 0? That's negative 16 times 0 squared plus 112 times 0 is 0. Oh, no. Yeah. So it was fired at 0 feet. It was fired on the ground, fired upwards. Okay, that makes sense. Now, sketch a general curve of the equation below. Let's grab our calculator. I typed it into y equals. I know that I'm not going to use any of the negative numbers, so I hit down arrow to get rid of those. And I mess around with the up and down arrows until I get something that looks like it's symmetric. What do I mean by symmetric? I notice that there's a 0 right there and a 0 right there. So that looks like the maximum height. Not quite. Okay, so I'm going to sketch it. Sketch the general curve. We know that it's going to be a little bit higher than 192. Through experience, it goes from 0 to 7. What do you mean it goes from 0 to 7? Right there. 0 to 7. Then it hits the ground again. From 0 to 7. Goes up, hits the ground. How high is that? It's a little bit higher than 192. So why don't I make that 200? And that's 0. There's a sketch. It doesn't say make a good sketch, it says make a sketch. Algebraically, find the time the rocket reaches its greatest height and the maximum height. Okay, let me see. Maximum height is right there. So, what do I know? That looks like the line of reflection. So that's the line of reflection. There used to be an equation about that. Oh yeah, that was the last equation in the previous lesson. X equals negative b over 2a. That's going to be the highest point. We take a look at the equation, and it is negative 16t squared plus 112t. Wait a minute, is there no b or is there no c? There's no c, okay? It's plus 0, and that equals f of t or h of t. It said it was an h of t. We'll change that to an h. Okay, so we know that b is 112, and a is negative 16. Plug it in. I put everything where it belonged. I grab my calculator, and I just type negative 112 divided by, now hey, if I do 2 times negative 16, I'm going to get the wrong answer. So I do parenthesis, negative 2 times negative 16. I'm going to get the same answer. I'm just changing the signs, close the parentheses, and I get 3.5. That's x. So x is 3.5. What did it ask for? Find the time that the rocket reaches its greatest height, the maximum height. Its greatest height and the maximum height? Same thing. Label these on the graph that you drew in part B. Okay. The time that it reaches the greatest height and the maximum height. So the maximum height is the y part. There we go. Grab my calculator. I can type 3.5 into the equation, or I can say second table set let's start at 3.5 and look at the table, and it'll give me the answer at 196 feet. See, it wasn't 192 feet, it was 196 feet. How did I know that? Because you can't have the symmetry there. You know, it can't be 192 and 192. It gives you a flat top. Parabola has a curve. So this is 3.5, 196. It said label that point. There we go. We got it. So why don't we just say the time is 3.5 seconds, just in case, and 196 feet is the height. Why are we doing that? To make sure that we answer the question. Okay, we have the answer there somewhere on the paper, but it's not my job to interpret it as the person grading the paper. It's your job to clearly tell me what is happening. Algebraically, determine the time when the rocket reaches the ground. Algebraically, we know the answer is going to be 7. Label this on your graph. There it is. It's labeled as 7. So let's figure it out algebraically. The ground. That's when the height is 0. What represents the height? Y represents the height. So I have to have 0 equals negative 16t squared minus plus 112t. Let me see. It looks like it's a quadratic. I got to solve it for 0. Factor it. So you type in your calculator 112 divided by 16 and you get 7. So you factor out 16. I was going to factor out negative 16, but let's just factor out a 16. And I'm going to factor out a t. And I get negative t plus 7. That equals 0. So either 16t equals 0 or negative t plus 7 equals 0. Let me see. This is very easy. T is 0. That's the beginning. Now here, I can either subtract 7, but that might be a little confusing. So I'm going to add t, and I get 7 equals t. You get there faster. So the time is 7 seconds. It's already labeled on the graph. That's it for number 1. You got any questions? Make sure you ask me. Let's go on to number 2. A skateboard half-pipe ramp has the shape in the form of a parabola whose equation is y equals 6/100 x squared minus 1 2/10 x plus 7, where x represents the horizontal distance of a 20-foot wide half pipe. Stop it. So what do we know? We know that it's going to be 20 foot wide. Okay, that's going to be 20. And y is going to represent the height. Okay, so now I know it stops at 20. The domain stops at 20. Starts at 0, stops at 20. With the help of your calculator, sketch a graph of the half pipe below. Label its height and its endpoints with a minimum point. Grab our calculator. I know that I'm going to start at 0, so I went to the table setup, second table set, and start at 0. Now let's take a look at the table. And there it is. And we notice that it's going up, 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 and then actually down. It goes from 7 down to 1.06, then down to 1. Let's see what happens after 1. So here I am at 10, and I down arrow. Oh, and it starts going up to 1.06 again. Okay, well, wait a minute. This is 20 feet. So I got to go from 0 to 20. Cool. So let's take a look at the window. Window from 0 to 20. And I really don't care about anything below ground because I know that the lowest thing is 0 feet. And let's graph that and take a look. There it is. This is exactly what it looks like from 0 to 20 because it stops. It's only 20 feet wide. Let's sketch it. It's how high? 7 feet. 1, 2, 3, 4, 5, 6, 7. 7 feet. Here's the spot where we sketch it. We know at 20 feet, it has to be 7. There we go. That's 7 high. With the help of your calculator, sketch the graph of the half pipe below. Label its height at its endpoints, 7 feet for both of them, and its minimum point. that point right there. It said with the help of your calculator. So when we look at the table, we're going to say, where is it changing? It changed right at 10. Remember that? Because those are 1.6. Well, how do I know that it really changed at 10? We go down on the table a little bit farther, and what do we see? That's not right. Let me go up. There we go. And we see that it's 1.06 and 1.24 on both of them, 1.54 on both of them. So we have the symmetry. There's that word again. There's the symmetry. So we know that this is going to be the minimum. 10 is the x value. 1 is the y value. So 10, 1. The point is 10, 1. I don't believe you. Okay, it says with the help of our calculator. Why don't we just do x equals negative b over 2a. We have the equation. Negative b is negative 1.2 over 2a. 2 times 0.06. This had better come out to be 10. Negative 1.2 is just 1.2, and 2 times 600ths is 0.12 or 12 hundredths. When you divide those two, we get, 10. Cool. It checks algebraically. Let's turn the page. The crazy caramel corn company has determined that the percentage of kernels that pops rises, then falls with the temperature of the oil and kernels that are cooked as the temperature increases. It models the trend using the equation. There it is. Okay, now there's something funny going on with this equation. I'll tell you why. Where P represents the percent of kernels that pops, and T represents temperature of the oil in degrees Fahrenheit. Okay, let me see. If I put in 0 degrees Fahrenheit, if I put in 0 for temperature, I happen to get negative 394 kernels popped. How can you have negative 394 kernels popped? We have to overcome this problem, and we will. Algebraically determine the temperature at which the highest percentage of kernels pop, also determine the percentage of kernels that pop at this temperature. Now remember, we're going to have the whole thing about parabolas. How do I know this is a parabola in the first place? Right there. It has an exponent of 2. Not just having an exponent of 2, but its greatest exponent is 2. So we have a t squared or an x squared, and the leading coefficient is I don't care. But it happens to be negative 1 over 250 in this case. But the fact is that it's a parabola. It's a quadratic because the highest exponent is 2. Because of that fact, when I want to algebraically determine the temperature at which the highest or lowest percentage of kernels popped, I know that I can use a very fun equation. You see that that's a negative? The leading coefficient is negative. That means it's a frown. The parabola is a frown. Negative equals a frown. If you're a negative person, I'm going to be pretty sad about it. Positive is a smile. Because we want to find the highest percentage of kernels popped, and it's a frown, we're going to find that point right there. Find it. I got it. It's right there. That happens to be along the axis of symmetry. So we can use x equals negative b over 2a. A is negative 1 over 250, and b is 2.8. Not because it's the first and second number in the equation, but because this is with the square. I said because this is with the square, that makes it A, and this is with the X, that makes it B. Got it? Good. Let's go on. Plug those in. Now listen, you've been doing math your whole life. Okay, I hope you've been doing math your whole life, and you see the negative divided by a negative is going to be a positive, so we can just get rid of those negatives right there. And then 2 over 250 is the same as 1 over 125. Well, I have some nested fractions here, so we're going to multiply by the reciprocal. We're going to go like that. So it is 2.8 times, I said 2.8 times 125 over 1. And that equals exactly 350. 350 what? That is x. And remember that the x is really the t, so the temp is 350 degrees Fahrenheit. Determine the temperature at which the highest percentage of kernels popped. Also determine the percentage of kernels that popped at this temperature. So you plug in 350 everywhere you see a t in the equation, and you hit equals, and we get 96%. I'm running out of room, so there it is. Using your calculator, sketch a curve below for p greater than or equal to 0. What? Wait a minute. I thought you said that x was the same as t. X is the domain. You're limiting the range here? You're saying the range that has to be greater than 0? Ah, remember, percentage pop. We're not going to have a negative range. We're not going to have a negative percentage of popcorn being popped. So we're going to go like that. We know for a fact that this point right here is 96, 350, 96. 350, comma, 96. How do I know that? That's just what we figured out in the previous question. Use the calculator, sketch a curve below, label your window. That means I want to know what that is, and I want to know what that is. We already know what that is 96. I type the equation into y equals, because it said use your calculator. And I go to the table, and I'm looking for y values being 0, because that's the height, that's the x-axis. We don't want any popcorn, we don't want to know when popcorn, negative 300% popcorn popped. So we go to the table set, second window, and that pops up, and you're like, about what temperature Fahrenheit would popcorn start popping? What about 100? Just using real world experience, real life experience. You're like, nope, we still have a negative. So let's go to second table set. What about 200 degrees? Take a look at it. Very close. So we can just start up arrowing until, there we go. There it is, 196 degrees. So the beginning is 196. The middle is 350. The difference between that, 196 and 350, is 154 degrees. This right here is 154 degrees. So that right there has to be 154 degrees. So 350 plus 154 is 494. There we go. I labeled it. If you got a question about that, ask. You can use your table and scroll down to see where it is. It's right around 494 degrees. Using the 0 command on your calculator, determine the nearest degree, the two temperatures at which it is exactly 0. 0 command. I grab my window. The left-hand side is 196. That's the X minimum. The right-hand side is 494. 494. That's the X max. Okay, and then the Y's. The Y maximum is going to be about, the Y minimum is 0. Why don't we make it -2? So I don't want to hit it that close. -2, and then the Y max was, I think, 350. Graph it. Okay, the Y max wasn't 350. The Y max was 96. So I changed that to 96, and we graph it. It's going to sit just at the top. We want to find the zeros. Missed it. It's not 494. See, I missed it. Let's make it bigger than 494. So I changed my window to 190 and 510. We're going to see it's really 504. Because I did the arithmetic. Bam. I'm going to change that to 504. Now it says use the zero function. So, second, calc. Choice 2 for the zero. Am I on the left-hand side? Nope. Let's get to the left-hand side. Do you see where I am? I'm right there. I'm the blinking star. So I'm going to move to the left below 0. I hit enter. Am I on the right? I'm going to move to the right above 0. Hit enter. Guess? I don't think so. Go ahead and hit enter. The 0 is right there, 195 exactly. Using zero command on your calculator, determine the nearest degree. 195. And get the other one. Here I am. Okay, I am on the left-hand side of where it crosses. Then I go down until I'm on the right-hand side. Yes, I'm definitely on the right-hand side. Do I want to guess? No. Go ahead and hit enter. The 0 is 504.91, so it's 505. Label it. And 505. Label them on your graph. Okay, so it wants me to change that to a 505. Thank you. If a typical batch of popcorn consists of 800 kernels, how much does crazy caramel corn expect to pop at the optimal temperature? 96%. So 0.96 times 800 equals 768. Okay, for a batch of popcorn to be successful, a company has to want at least 85% of its kernels to pop. Write an inequality for a solution that represents a temperature that would ensure the success of the batch. Solve this inequality graphically to the nearest degree. Show your graph below, labeling all relevant points. Hey, before we go on, I want to know that 32 don't pop. Why do I want to know that? Because I always want to know waste. Okay, as a business person, I want to know waste, what I lose. 768 are great, but hey, that goes out the door. I want to know what stays here as waste. What am I losing? For a batch of popcorn, okay, so we want at least 85%. So here's the inequality that we're dealing with. What? Well, remember, it said that it wanted at least 85%. So there's the 85%, and here is the at least part, okay? 85% we want, so that's 86%, so 80, I just said, so, 86 can be an answer. So 86, is 85 greater than 86? Absolutely not. So when you go through it, you can do that little test mentally, like I just did. So I had that wrong. So 85% has to be less than or equal to. There. Now, we're going to, 85. Now remember, this is the y-axis. And it says solve graphically. So we grab our calculator. I already have that equation typed into our calculator. What am I going to do? I'm going to also have y equals another equation, y equals 85. Okay, we can deal with that, but wait, this is an inequality. So let's go over the inequality side. And 85, when we hit enter, the color is red. We're going to not go to a line. We're going to go to, let me see, that's a less than. So y is less than 85? Nope, we want that. Let's just check it to graph it. There it is, and we want everything above that. Remember, we want the maximum to be shaded. Why isn't it shading it? Oh, I know, I forgot one thing on the calculator. When you hit y equals, go there, go over to the line, hit enter, say that I hit down arrow once. Now I'm hitting the left arrow, saying I want y to be greater than 85. I have to hit enter and hit OK. Now it's there. When I hit graph, remember, I want to have the maximum. I want to have the top part of that to be shaded. And there it is in the preview. We see it's shaded. So that is what we want the graph to look like. There's a quick sketch of the graph. Now we want to find these 2 points right here. Oink, oink. Find those 2 points. We can do that on the calculator. What do you mean? Well, we hit the second and we hit the calculate, and we will know where they intersect. Am I on the first curve? I'm going to go close to the point, hitting left arrow. Yes, I'm on the first curve. Am I now on the second curve near the point? Yes, I am. Guess, I don't think so. And it tells me that is what the intersection is. Nearest degree, 298 degrees. Do the same thing for the other side. And it gives me 402 degrees. So what were those steps to find the intersection? Number 1, graph both equations. Number 2, hit the second, the calc key, and then choice 5, and then get near the point. Hit enter 3 times, and you have your answer. Okay, now there's a lot of work that's coming up. So I'm going to have this as 2 days. Today, do page 35. Tomorrow, do page 36. If you got any questions, just give me a shout. I'll see you later.